Welcome to another exciting edition of Math Class. I'll be your host, and welcome back to Mr. Hall's virtual classroom. And welcome to this exciting edition of learning about the Pythagorean theorem. So, if you will join me on to page 351, we're going to be taking and diving right into the Pythagorean theorem. Dun, 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 dun. Okay, stop your yawning. We're about to learn something exciting here, so let's go ahead and talk about the Pythagorean theorem. When you are dealing with the Pythagorean theorem, you're going to be dealing with a triangle. And not just any triangle, but a specific type of triangle. Did I hear someone say a right triangle? Alright. So, that's right. Right triangle. We're going to take and we're going to put this triangle and learn about the legs of the triangle. And one thing a triangle has to equal, again, friends, was what? 180 degrees. Alright, so on this right triangle, this is going to be the leg. Hypotenuse is always the longest side, and another leg. Okay? So, leg, hypotenuse. Leg, hypotenuse. Now, when you get into a little more advanced math, you're going to learn, about the legs a little more in depth, being SOHCAHTOA, which means sine. You're going to learn about cosine and tangent, but not today here. But guess what? People who say you never use this, well, guess what? This is going to be the first step into your building of your set of steps. So, Pythagorean theorem states that you have a squared plus b squared equals c squared. C squared is always your hypotenuse because it's the longest side. So, again, if we have our triangle and it looks something like this, that means this would be C, this would be A, this would be B. Or you can do it backwards. You can go B, A. And they're all going to be squared. So, I want you guys, if you would, flip on over. We're going to, and this is a super short lesson, but it's, it can be a little tricky if you write your legs and your hypotenuse wrong. So, let's go ahead and look at example 1. Example 1 says that find the length of the hypotenuse of a right triangle. Alright, so first of all, I'm going to draw our right triangle right here. Again, just so you know, every time you see a square, that means it forms a right angle, okay? So, we're given the legs, and it says the legs are what? 5 and 12. But we do not know what C is. Well, guess how we're going to find that? We are going to put the Pythagorean theorem into place. So again, what is the Pythagorean theorem? It is a squared plus b squared equals c squared. Now all I'm doing right here is literally just placing in the numbers that we know. So I know what a squared is. It told me it's 5 squared plus 12 squared equals c squared. Well, that I do not know, so I'm going to have to solve for it. Can someone tell me what 5 squared is? 5 squared is 25. 12 squared is 144. Equals c squared. So next one I want to do is I want to add the 25 and 144. And what does that give me? I'm going to write it down over here to the side so we can see it. 25 plus 144 gives me, I think it's 169. Yep, 169. Alright, so in order for me to figure out what my square root is, I'm going to have to square the 169. Okay? So, can someone tell me what the square root of 169 is? What perfect square gives you 169? And if you need to put it in your calculator, you're welcome to do so. So the square root of 169 equals 13. So we can go back and put 13 for C. And we have solved our first right triangle side that was missing. So if you guys will pay, I'll go ahead and write it up there, that way you can see where the 13 goes. So our sides are 5, 12, and 13. Alright, let's go on and try another example. Let's look at example 2. This one says, find the length of the hypotenuse of a right triangle if the length of the legs. So again, we are given the legs. We have right triangle. It says the length of our sides are 5 and 7, but we do not know what C squared is. So we need to write our Pythagorean theorem. A squared plus B squared equals C squared. And start substituting in. So here we got 5 squared, 7 squared, and do not know C. So 5 squared is what? It is 25 plus 49 equals C squared. Alright? So, if we add 25 and 49, that tells us C squared is the square root of 74. Because you want it to be C equals, okay? And what I mean when I say C equals, this right here is just going to be C, okay? These sides are A, they don't read A squared. It's A, B, and C. Okay, you just put squared in your Pythagorean theorem to solve. So C, if you want to just take this out for a moment, I'll write it over here. C squared equals 74. To get rid of a square root, you have to square it. To get rid of a square, you have to take the square root. Okay, so that means I have to square this side and I have to square this side because I want it to say C equals. You can leave it as C equals the square root of 74 if you want, because it doesn't have a perfect square. Or you can square it, go ahead and do it, and put it in your calculator. And if you take the square root of 74, you get 8.6. So we got 5, 7, and 8.6 as our sides. So, quick recap of what just happened here. We were given sides A and B, which are 5 and 7. I went back and put them in the Pythagorean theorem. I put 5 for A, I put 7 for B, and we didn't know what C was. So I went and took the square root of 5, 25, took the square root of 7, 49. Added them together, it gave me 74. I took the square root and the square root to get, because I wanted just C equals, not C squared equals. So that gave me, when I put that in there, the square root of 74 is 8.6. And that was our missing side. So, does that make any sense, or are we all confused?
What?
Yeah, so I'm thinking, how do we get that? I'm a little confused myself. Alright, but I thought if we do enough of these, they'll be... That's the reason I'm trying not to rush these lessons. I want to make sure that you guys are grasping the material. I know some of it is a lot easier than other portions that we're doing. So just take time. Again, don't try to fly through it. You guys have plenty of time. And again, you guys have my phone number if you have any questions. So please feel free. Call, text, video conference. It's all available to you guys. Just don't shy away if you don't understand. Please feel free to ask questions. Alright, let's look at our last example here. It says, find the length of the leg of the right. So, in the previous one, we knew what? The previous one, we've been given 2 legs. This time, we weren't. We're actually given just a leg and the hypotenuse. Alright, so let's go ahead and write that. So we're trying to find A, but it gives us B and C. It says the hypotenuse, which is going to be the longest side, is 14, and the leg is 8. Wow, that looks a lot different, you say. It does, but here's the kicker. All you're doing is still writing down your Pythagorean theorem, but this time, since you're trying to solve for A, you have to write it like this. C squared, well, I'll put A squared first. A squared equals C squared minus B squared. And bear in mind, that's a minus, okay? What do I need to do next? I need to put the numbers I know to be as substitution. So I don't know what A is. I know C is what? 14 squared. Minus, well, what is side B? 8 squared, which is, so this is going to be 64 when I square that. 196 when I square this. So someone tell me what we get when we subtract 196. So right now we're at A squared equals, that gives me A squared equals 132. I can't leave this as a square because I need just A equals, not A squared equals. So I have to take the square root of this, and I have to take the square root of that. So that gives me A equals, and does 132 have a perfect square if you put it in your calculator? No. So you actually get the square root equals 11.5. So we know now side A equals 11.5. And one thing I'll tell you, a quick checkpoint, if you're curious, if you're right, your legs will never be larger than your hypotenuse. So your legs will never be greater than your hypotenuse. Okay? So if this number was larger than 14, it was incorrect. So if 11.5 had been larger than our hypotenuse, it would have been wrong. Alright. So, my dear friends, I think that will bring us to the end of learning Pythagorean theorems. But if you do have any questions, please again feel free to call. You guys have, I think your packets got mailed out, so you guys should have all the information you guys need. And you guys have your book for reference. You got me for reference. So if, like again, if there's anything you guys feel like, well, I kind of get it, but I don't, please feel free to call and ask, and we'll get you guys taken care of. And with that being said, it looks like our time together has come and gone. So thank you for tuning in to another exciting edition of Mr. Hull's Virtual Classroom, and I'll talk to you guys later.